Hello everyone, welcome back to CodeMaster. In today's video, we will tackle two essential linked list problems in Python. Before we dive into coding, here's what we will cover today. First, we will learn how to reverse a linked list, followed by detecting a cycle using Floyd cycle detection algorithm. These concepts are frequently asked in technical interviews, so mastering them will give you an advantage in interviews. A linked list is a data structure where each node contains two parts, data and a reference to the next node. Unlike arrays, linked lists don't store elements in continuous memory, making insertions and deletions efficient. The three main types of linked list are singly linked list, doubly linked list, and circular linked list. Let's start with our first problem, reversing a linked list. Our goal is to change the direction of the links so that the last node becomes the first. We will use an iterative approach with 3 pointers: previous, current, and next. Now let's look at the implementation. Here's the Python implementation. I will explain it line by line. First, we define a list node class to represent each node in the linked list. Each node stores a value and a pointer to the next node. Now we define the function reverse linked list. We initialize previous as none since the new tail will point to nothing, and current starts at the head of the list. Now we loop through the list. First we store the next node in next node. Then we reverse the next pointer to the current node to point to the previous. Finally, we move the previous and current forward by one step. Once we reach the end, previous will be the new head of the reverse list. So we return it. Since we only traverse the list once, the time complexity is order of n. And since we don't use extra space, the space complexity is order of 1, making this an efficient solution. Now let's move on to our second problem, detecting a cycle in a linked list. A cycle occurs when a node links back to a previous node, creating an infinite loop. We will use Floyd cycle detection algorithm, also known as the two-pointer method. Let's go step by step through the implementation. We define a function has cycle. We initialize 2 pointers: slow moves 1 step at a time and fast moves 2 steps. Now we use a loop. If fast or fast dot next is none, the loop will stop, meaning no cycle exists. Otherwise, we move slow 1 step and fast 2 steps. If slow and fast meet at same point, it means there is a cycle and we return true. If the loop ends and the pointers never meet, we return false, meaning no cycle was found. Since we traverse list at most once, the time complexity is order of n, and since we only use 2 pointers, the space complexity is order of 1, making this an optimal approach. Let's quickly recap what we learned today. We covered 2 key linked list problems: reversing a linked list using an iterative approach, detecting a cycle using the Floyd's cycle detection algorithm. Both of these problems are crucial for mastering linked lists in coding interviews. In the next video, we will discuss about the bubble sort algorithm. If you found this video helpful, don't forget to like, share, and subscribe to CodeMaster for more coding tutorials. Let me know in the comments if you have any queries or questions related to this. Thanks for watching and see you in the next one.